Hello everyone. Let us now discuss how can we solve this problem. Count equal and divisible pairs in an array. So we are given with a zero indexed array nums of length n and an integer k. Return the number of pairs I comma j where 0 is less than or equal to I less than j less than n such that nums of I is equal to nums of j and I into j is divisible by k. So if you see here, this is the first example given to us. So I am taking the indices of this array. So if I write the indices 0 1 2 3 4 5 and then 6, I need those elements which are equal and the indices when multiplied should be divisible by k. So now I am taking first thing 0 and 1. Are they both equal? No. Then just skip that and go to next index. Are they both equal? 3 and 2 are not equal, so skip and go here. 3 and 2 are not equal, so skip and then is not equal and then this is not equal and then go here. Now I have 0 as I and 6 as j. These both will result in 0 and 0 percentile. 0 is divisible by k. How? Because 2 into 0 will give us a 0, right? So that's why I am taking this as one pair. So till now the count of the pairs which are uh, like equal and divisible pairs are till now 0, but when I get this 0 and 6 I am incrementing to 1. Now I am taking this 3, so I am taking this I index to here and then this j index to here, right? 1 and 2. Now are they both equal? No, they both are not equal. So next I am going here. Are they both equal? 1 and 2 are not equal. 1 and 2 are not equal. 1 and 1 are equal. So 1 into 5, 1 into 5 will give us 5, but 5 percentile 2 will give me 1 as the remainder. So that means 5 is not divisible by 2. So we don't increment our count. Now let us go and check the next index. Here 3, 1 and 3 are not equal. So come here and here it will be 2. Now 2 and 2 are equal. 2 and 2 are equal. They are indices 2 and 3. So 2 into 3 will give us 6. So 6 is divisible by 2. 2 into 3 is 6. So I am incrementing my count. Now I am going to the next index 2, right? Sorry, 4. So 2 and 2 are equal and I have 2 as I and 4 as j. 2 into 4 is 8 and I am incrementing my count as 8 is divisible by k. Now I have 2 and here 1. So here 2 and 5 is not equal, right? 2 and 1 are not equal, so I'll skip it. So then I'm going to next index. I'm going to next index 3. So 2 and 3 are not equal, so I'm skipping that. Now I'm going here the next index and this is I. So now 2 and 2 are equal and they are at 3 and 4. 3 is index of I, 4 is index of j. 3 into 4 will result in 12. So count is 4 because 12 is divisible by 2. Now, is there any element right? So let us check. So 2 and 1, they both are not equal. 2 and 3, they both are not equal. Now, here I have to go to the next index here and then checking j from here. So 2 and 1 are not equal. 2 and 3 are also not equal. Now 1 and I am going the j from I plus 1. So these two I 1 and 3 are not equal, so I'll return the count of 4. So what I am doing here is taking I from 0 to less than n, and j will be I plus 1, right? J will be I plus 1 if nums of I is equal to nums of j. Firstly, we are checking this, and I'm checking for another thing, which is I into j, percentile k is equal to 0. Then I am incrementing my count. So don't forget to initialize count is equal to 0, and at last I will be returning the count. So this is how you solve this problem with just two loops, which takes us a big O of n square time complexity, which is also okay with the given constants. So if you like this video, do share it to your friends and do subscribe to my channel. Thank you.